So good afternoon, everyone. Welcome to this edition of the NITheCS Colloquium. We had a little break because of the too many public holidays, but we are back in action. And this afternoon, it's a great pleasure to have Dr. Farai Mlambo with us. Farai is a senior lecturer in digital business and data analytics at the Wits Business School, yeah, and he's also a fellow of the recent Wits Mind Institute. I don't remember what MIND acronym stands for, but I'm sure you will tell us just now. Yeah? He's also in charge of the postgraduate diploma in digital business, and he leads the statistical machine learning, data science, and analytics lab. Yeah? And this afternoon, he will give us a very interesting talk about the golden age of statistics, and we will find out if it's a golden age for statisticians as well. Yeah, so Farai, thanks very much for coming the long way from Joburg. Yeah, and please, you're most welcome to start your presentation. Thank you very much.
Thank you. All right, good afternoon, everybody. I trust you're well this afternoon. Hope I'm audible at the back. Awesome, great. Okay, so like Prof said, I'm from Wits. I really came into the friendly side of town. I think a bit busy in Joburg, but I'm excited to be here. Well, I'm at the business school, a bit lost there. I'm from the mathematical sciences. I was in the School of Stats and Actuarial Science for about 7 years. I'm also part of the Machine Intelligence and Neuro Discovery Institute, which comprises about 34 people from across fields, psychology, computer science, and anatomy, and different other things, but to do with Africa producing its own artificial intelligence, as it were, and not just be consumers of artificial intelligence. So, I mean, look, the talk today is really focused around statistics and repositioning what statistics can offer within the framework of artificial intelligence and neural networks and other forms of machine learning, as it were. So please just sit back and relax, and let's discover what Prof was talking about just now, whether it's also a golden age for the statistician. That's what we want to talk about a bit. So it's just an overview of what the talk is really all about. We'll give, of course, some form of motivation and the background to the thought and some historical foundations, shedding light on the historical developments within the field of statistics. And we'll talk about some pioneering contributions of statisticians and how that fits in the framework of data science, machine learning, and artificial intelligence. And we'll go all the way with the evolving role of statisticians and maybe do a bit of prophecy, trajectory, etc., where we are going in terms of the need for statistical thinking, etc. So I mean, just to throw something there in terms of the proposition I'm bringing here, I think statistics is the backbone of trustworthy AI. So before you can trust AI, one has got to ensure that it is statistically sound, and that is what I'm really going to talk about today. The idea of machines being clever. How do we make machines clever? They've got to learn from data, and learning from data is statistical in nature, and that is the proposition. So, of course, we'll talk a bit about data science and what data science is all about, etc. This is just some underpinnings of why the topic really matters. The value of statistics within machine learning and artificial intelligence is often underestimated, underappreciated, misunderstood, and neglected. And statisticians are essentially stewards of interpretability and rigor and validity of models, as it were. And of course, we'll talk a bit about ethics, etc. But the point is, think about a data scientist as someone who is a statistician who is better at programming than an ordinary statistician, and or a programmer who is better at statistics than an ordinary programmer. I think that's a mouthful, I guess. But the whole point here is statistics lies, so rather data science lies at the intersection of statistics and programming. And one could see that better if you think about a data scientist as a collaborative problem solver that brings mathematics, statistics, computer science, and domain expertise to make meaningful and impactful solutions. Of course, with regards to interdisciplinarity, you're also talking about communication. You must communicate the problem. The problem must be very clear. What is it that you're trying to achieve, etc. I think this picture, the next one here, this one here, gives a nice overview of what we're talking about when we're talking about a data scientist. Okay, so why am I doing this? Because I think data science becomes like the glue from statistics to artificial intelligence. You will soon see it now. So I mean, think about some unicorn sitting there in the middle where they actually can understand the business problem. By the way, I'm from a business school. That person should also have a strong foundation in maths and stats, but then they should be able to actually execute the maths and stats on the computer in form of programming. So someone sitting there is someone that you would call a data scientist. Of course, machine learning, what is less about the problem, as it were? I mean, the worry there is just to develop some algorithm, etc. But we can also talk about traditional research and software development, etc. So, I mean, if one wants to become a data scientist, you can just about imagine that if you are sitting there, you're lacking some maths, and you just need to add maths to become a data scientist, right? If one is sitting there, you don't understand the business problems. So you probably just need to understand the business problem to become a data scientist, etc. But of course, the idea is not to train data scientists today. So let's move. Just a more overview definition type of thing, of course, combining those three domains from the picture. I think there's not much to say there, but the point is that true data science lies at the nexus of those pillars, balancing the technical sophistication and contextual relevance. Okay, this is more interesting, I think, because in the room we might be having people who sit here, the stats profs. I can imagine that they probably just need to move this direction if they want to become data scientists, or maybe they're actually trying to go as far as possible from this, as long as they don't go all the way. So for sure, if you like the stats, then you become hot air there, which is the media, right? But then you also have the R core team there, with a lot of programming and stats, but not necessarily the communication and the business, right? Then, of course, you've got the accountant there who doesn't have the stats, neither do they have the programming, etc. So it's kind of interesting. You still have the salesperson there who can communicate the business, but they have no stats, they've got no programming. And yeah, maybe they're also sitting in the room. If they want to go up here, I guess they can just see what they need to add there. But let's move a bit. The main picture is still coming. Okay, let's look at this picture here. So the role of statistics in data science. So these are like data, they call them what? Data professions. Data professions. So you've got your data engineers, the green part there. You can see it's more like pipelines and dashboards and type of things, right? Databases and data tools. But then if you move coming this way, you see that with data analysts, there's need for a bit of visualization and storytelling and business insights and, of course, reporting. I guess this is where the chat GPTs are helping them a lot. Etc., and the Geminis, etc. But I mean, if you think about a data scientist, there's more need for inference. I want to emphasize that term there because I think it's really the statistics profession that takes that problem seriously, the problem of inference. And that is very important because, I mean, your data is not the population, of course. Your data is a sample, or your data is meant to be a representative sample. But the point is, how representative is it, and can you generalize from the sample to the population, etc.? It becomes very important in data science, which brings me to my famous quote, which I say statistics is actually the science in data science. So I think about inference as the pillar of generalizing your results from your data to the population you intend to understand, etc. But of course, the machine learning engineers, they also come in there, but they focus on model development, etc. Not necessarily the inference. I'm sure you can see the difference there. Okay. Some takeaways there. It's more reading for those that would like to read later, but I think what we've mentioned is really what is on there. So statistics remains an indispensable language that transforms raw data to scientifically validated insights, differentiating true data science from mere data manipulation. So data science is really more than a Kaggle project, where you can find pre-written code to do ABC. I think it goes beyond that. That's the idea. So, I mean, please allow me to just take you through this. I mean, if you should see the slides, you see that there's links here to the papers, etc. So this is more like a historical overview of the field of statistics. It's going to become very interesting soon. One thing to note here is that the origins of the discipline actually came from application, the need for application in the agricultural sciences, etc. That's where some of the work actually emerged, in the early days, etc., to do with chi-square tests, and there was a bit of formalization from that time up until the 1950s. There was a lot of mathematical emphasis that came through there. You see it now in a nice, good picture. But the main point is application was the important thing when statistics actually originated, as it were. So now data science seemed to bring statistics back to applications. Of course, after 1950, when you got the, did I go too far? When you got people like Tukey, actually he wrote a very controversial paper where in 1962 he talked about the future of data analysis, which is assumed to be what data science has become today. I think he was kind of prophesying about data science. That's like almost 80 years ago, right? So he actually was supporting the fact that statistics must become more application-oriented and not just a mathematical discipline, not a sub-discipline of mathematics, but something that is meant to solve application and practical problems, etc. And of course, that's the time also that the electronic computer had arrived, and so there was a tension between mathematical rigor and practical relevance, and that set the stage for modern data analysis. So people like Frederick, Mosteller, and Tukey, they are really the pioneering ideas behind data visualization, etc. Your exploratory data analysis, etc. And of course, now coming to survival models, and I mean, the bootstrap is highly computational. Computationally intensive, the idea of resampling. And it has become a very important idea when you want to talk about estimation, etc. Bradley Efron. He wrote a nice, good book. In fact, what I'm summarizing here is actually from Bradley Efron's book with Trevor Hasty, who happens to come from Cape Town. Sure. So let's move a bit. So, of course, around this time here, random forest, etc., that's where now, you can see the rise of data science and emphasis on algorithms, etc., more computational power. By the way, artificial neural networks were discovered both in statistics and in the computing science in a parallel fashion. I think projection, pursuit, and of course, double descent in the computing environment. So what is the story here? The story is just to paint a picture of the contributions of statistics. You can trace it from the beginning where we started the student T, hypothesis testing, and confidence intervals, and of course, everything to do with maximum likelihood. This is what data science is actually utilizing to actually get to good results, etc. But then, of course, think about the lasso, regression, shrinking, and all the way to random forest. They've become very popular, tree-based techniques, etc. These are all statistical type of techniques. And of course, beyond this, there's been a lot of other contributions. Okay, before I get there, this is a hopeful future. In fact, the authors of the book I was referring to now, Bradley Efron and Trevor Hesty, they actually say in an interview that they hope that we'll get someone that can come and put data science on a strong inference footing like was done to statistics, which I don't know if it will be possible to do that, because I think there's just too much going on in terms of computational algorithms, etc., without any footing in inference. And this is where the statistician really is expected to play their part. So here's some nice, good books. Of course, I think most of the people sitting in this room probably know this. I'm trying to paint the contribution of statisticians. Of course, a lot of people know about machine learning, but maybe not statistical learning. So, of course, statistical learning has been a response of statisticians to machine learning by emphasizing statistical rigor, etc., etc. And I mean, the good thing with this book actually is that it comes with a lot of resources over there, including Python and R code and free data sets. Even the book you can download even from the website. It's a free book. Very solid introduction to statistical learning. And it is accompanied by, of course, this is just a bit of description about the book, the authors, etc. Supervised versus unsupervised learning with a strong statistical perspective. Okay, so building from linear regression and multiple regression and discriminant analysis and classification methods, random forest, etc., all the way up to artificial neural networks, but emphasizing interpretability and all that type of stuff. Okay. You should be, someone should have picked up already that I'm a lecturer, right? I'm presenting this as a lecture. But I mean, this is a very mathematical version of the book I just showed you now. It's called Elements of Statistical Learning. So here you go into all your shrinkage methods and you go to nonlinear techniques such as splines and wavelets and things like that. But the emphasis is to establish how the computer can learn from a statistical point of view. Because I think this becomes very important to the things we're talking about. Sure, emphasis on kernel methods and in-sample methods, of course, statistical learning theory, which kind of integrates machine learning algorithms, with interpretability and of course the variance bias trade-off is very important. I'll touch a bit about that a little later. Okay, so this of course is regarded as an essential text for statisticians and data scientists and machine learning practitioners. In fact, I don't think there's anyone who is practicing machine learning properly without having looked at this book. I don't think there is anyone who is practicing machine learning properly unless if they're doing Kaggle type of work. Okay, so then let's move a bit. I like what this author says here. This is Larry Wesserman. He says something very striking here in one of his books, which is called All of Statistics. Statistics, data mining, and machine learning are all concerned with collecting and analyzing data. For some time, statistics research was conducted in statistics departments, while data mining and machine learning research was conducted in computer science departments. statisticians thought that computer scientists were reinventing the wheel. Computer scientists thought that statistical theory didn't apply to their problems. Things are changing. Statisticians now recognize that computer scientists are making novel contributions, while computer scientists now recognize the generality of statistical theory and methodology. Okay, I think that's a very powerful statement. So again, it's showing the intersection of programming and statistics to actually yield what we would call a data scientist. Okay. Again, this book is also freely available. There's a link there in the when I share the slides. Whoever wants to check, there will be links on the title there to get to the book. Okay. Let's move. It comes with R code, blah blah blah. Okay, this is now becoming interesting. So here is a book on what is called interpretable machine learning. So what is interpretable machine learning? Interpretable machine learning is machine learning models that are really meant to uncover the black box, as it were. You know, artificial neural networks, you throw something in the box, you get an output, you don't know what happened. Okay. But then interpretable machine learning, this book is actually written by a statistician. That guy is a statistician, Christoph Mona. In fact, all the books I've been sharing now, they're written by statisticians. There's different things you can plot. For example, partial dependence plots. You know, you fix your features. They call them features in machine learning, or independent variables, whatever. You fix them and you change one, and you see how it changes the prediction. And then you draw a plot, and you see, okay, there's a positive relationship between the feature and the prediction. Very powerful ideas. And again, this book is freely available. But the whole point here is to bring some interpretability to black box models. Okay, very important. All right, let's move. This is very important. This is now the book I was actually referring to earlier when I talked about the history of statistics, etc. So they give a nice background of what statistics has been for the last 100 years, as it were. These two colleagues, Trevor Hastie and Bradley Efron. And there's a nice good picture that they actually draw in this book here that I'm going to show you very soon, where they track the discipline from 1906 or 1908 up to 2016, and they show that there's been emphasis on applications when the discipline began, but then it moved towards the mathematical end until the computer arrived. I think the electronic computer actually saved the discipline from becoming mathematics, and that's quite interesting. I'll show you now. So this is the picture I'm talking about. So is it where you can see that the discipline actually started from the need for applications in agricultural experiments and sampling and. But then I think it was almost captured by mathematicians who were saying, you know, we must put mathematical rigor on this type of methods at maximum likelihood, blah, 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 student T, you go further down there. Up until 1950, when the computer actually arrived, and then things became more practical, going back this way. And of course, the hope is for the discipline to stay in the middle there. But I don't know if we are closer there, you know, with data science, which seems to be kind of regarded as an orphan. I don't think data science has got a parent. It looks like it's an orphan who tends to sit in a different home than where they're supposed to sit. Of course, that's a joke. But let's move. Okay. So the key insights, of course, here is intertwining data science and traditional statistics and blending with computation, applications, and theory, the theory being the maths, of course. This is where we hope to be sitting. But I think there's a big challenge in how data science programs are being, I'm also speaking from the education side of things. Sometimes there's too much emphasis on computation and a bit of neglect of the theory. Sometimes there's too much emphasis on applications. I've checked quite a few programs on data science, etc. So the idea is to really get a blend of the theory, the stats, and the computation. Yeah, but we hope that we get there. A bit of contributions here, just a picture of contributions of statisticians based on the previous things I was talking about. Of course, people like Pearson with the chi-squared test, still very instrumental in quantitative analysis, and whenever you're dealing with categorical data, etc. Very, 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 very important stuff. Of course, with the ground that is put also on PCA, principal components, etc. You talk about student T distribution, very important stuff, of course, for small samples. I'm an advocate for small data. I know people are talking about big data, but I don't think we have big data. That's a conversation for another day, I think. Ronald Fisher talks, of course, he did a lot of work on maximum likelihood, which is the basis of most of the parameter estimation that we have in most of these packages, etc. Of course, one can imagine the importance of hypothesis testing. The framework of hypothesis testing is very important. You can see that a lot of work was done back in the days already, 1933, confidence intervals, 1937, and the foundations of statistical decision theory. And again, this is the stuff I was talking about when the computer came in, and now you see exploratory data analysis, which is very important. One has got to look at the data before you can do complicated stuff. And of course, professional hazards. This is just a summary, of course. This guy did a lot of work. I think he's under-celebrated. He's a South African guy now in the States. I couldn't put most of his papers here. I think there's a lot of work that he has done. Statistical learning. Okay. A few questions to make you ponder. Is machine learning a sub-discipline of statistics? Or is it an independent field? Of course, that's something to think about. Can you trust black box models, such as artificial neural networks, etc., for high-stake domains such as healthcare and criminal justice, if you like? Does interpretability come at the cost of accuracy? Or is that a false trade-off? I think the fourth question is quite interesting. Are data scientists just rebranded statisticians, or you like to say applied statisticians? Or is it something fundamentally new? But we're told that there's nothing new under the sun. So I think I gave my answer away there, or rather my view away. But someone could think of a data scientist as some new thing, but I don't think it's a new thing. I think it's really statistics done on a computer. Then, of course, there could be other bigger questions one could ask about AI. Is it overhyped, etc.? But I think question number 9 there becomes very important as well. Talking about causal inference. Yeah, sure. Okay. Okay, this is where we are trying to now kind of look for the brake pedal. But we need to think about the role of statistical methods and the role of statisticians in this age that we're living. Okay, so one cannot disagree with the fact that the term data science is kind of overtaken statistics in public discourse. People are more excited when they hear that there's a data scientist in the room than when they hear that there's a statistician in the room. Okay, so And of course, statistical thinking is embedded in many fields. And this is the thing I was raising, or rather, I'm trying to postulate here that I think it's a golden age for statistics, but maybe not for the statisticians, because everyone is becoming a statistician. Everyone is practicing statistics. I think even engineers, physicists, biologists, everyone is practicing statistics. So it's a golden age for the discipline, but maybe not for the practitioner. You know, something to ponder about, particularly from the discipline side of things. Is there something that the discipline is not, or rather the practitioners are not doing well? I like what one of past statistics presidents say. I won't mention the name, but if I give away that it's a she, probably no. She always says that engineers are taught to sell themselves, but statisticians cannot sell themselves. So that's a joke for the statisticians sitting here. I don't know if there is any, but there's been a rise of black box models, of course, emphasis on automation and deep learning, which has overshadowed foundational statistical principles. I mean, the very principle of the error variance trade-off, which is a very key principle in statistics, there's been some evidence that shows that it's not valid from a computational point of view, where they talk about, yes, the error goes down and it goes up, but then if you give more data, it actually goes down again. They call it the double descent thing. I recently did a bit of writing on it. So some of the black box models have kind of challenged the very foundations of statistical models. You know, because maybe some of the findings we got, yes, they were proven mathematically, but also they were done with small data and all that. You know, and now big data is proving otherwise. But statisticians are uniquely positioned to bring rigor, of course, interpretability and accountability, and they've got to embrace this interdisciplinarity, which is not always evident. You find that sometimes the decisions want to sit in their own corner as well and say, you know, we are the original data scientists. But then I guess the point is one has got to think out of the box and work together with other disciplines. And okay, probably preaching to the converted there. Can you imagine the bus going and the driver is outside? I think that's exactly where we're sitting. The bus is leaving, but the driver is outside the bus. So data science and AI revolution really is like a fast-moving bus powered by statistics. But statisticians who build and understand the engine are often left standing outside. You know, for sure, there's a call to action for statisticians to really step back into the driver's seat, as it were. Let's look at a few other things before we close. Of course, probabilistic modeling. There's been a rise on uncertainty quantification and the need for this. For models to know when they're wrong. So you don't want to just have a good model, but you want a model that also knows when it's wrong. I mean, for example, ChatGPT does not tell you that it's wrong. ChatGPT is always right. Okay? But I think it was going to be nice if ChatGPT could say, here is my answer, but I'm not sure. But ChatGPT does not say that ChatGPT is not sure about the answer it's giving. So in other words, it's not quantifying the uncertainty. And really, this is a field where Bayesian inference really shines here. Bayesian inference shines in probabilistic and uncertainty quantification, etc. And of course, inference, we touched on inference earlier, validity and design. Very important for primary data analysis, etc. Colleagues within the application fields such as management, etc. They really focus a lot on internal and external validity, etc. Of course, rigorous evaluation of metrics or rather evaluative metrics. Also, the one has got to emphasize out of sample validity. So these are all statistical kind of principles: cross validation, bootstrap, blah blah blah, etc. Okay, just a bit of citizenship. I'm just showing some of the citizenship I do here. I think NITheCS is a great marketing platform, right? So I mean, look, there's about 40 of these things where I was trying to emphasize that statistics is the science of data science. Statistics is the art of turning data into knowledge. Machine learning is statistics rebranded with computing power, blah, blah, blah. A lot of controversial statements, right? But I guess that's what social media is all about. You just throw something controversial and you leave it there. Supervised learning is statistics with labeled data. Okay. Deep learning is machine learning at scale. Of course, this kind of reasonable. But natural language processing is statistics applied to text. Very controversial, right? Yeah, if you post controversial stuff, you get a lot of likes. I mean, look, the evidence there. So, data science is statistics applied with computation, right? Artificial intelligence is a science of creating machines that learn from data. So the emphasis here is really that artificial intelligence is nothing but statistics that is framed, and you have got machine learning. Of course, once you've got machine learning, then the moment you've got an audience, then you're talking about artificial intelligence, right? So it's kind of exciting that it's the same thing you're dealing with, but it's really the packaging, right? If you package it well. By the way, the colleagues that I take there, we're actually kind of working on a paper on some of the ideas that is in this presentation. So I think Inga is our outgoing. I think these two colleagues are actually very powerful in the statistics community. They were both SASA presidents. Warren Brittany and Inga, they were both presidents of the South African Statistical Association. So we're also trying to just say statistics is very important in the data science community, as it were. And I think this is what I'm talking about here. So let's just finish up a bit with a few things. I'll pause a bit for you to look at this. I think this is kind of interesting, right? So, I mean, no insult intended to the computer science colleagues, but I mean, look, really, yeah, they're looking for a friendship, right? But then let's work together, teach me statistics. I'm now a data scientist. So, yeah, of course, I mean, a lot of people want to learn Python, they want to become data scientists, but who wants to learn math? No one wants to learn math, right? This is very exciting, I guess, these two. I think the idea here really is that data science is really rebranding statistics. So if you don't know how to do data science, you must see what the statisticians are doing in stats, and then you kind of copy it. Then you are a good data scientist, right? Okay. Yeah, a bit of reading there, but I don't think I should waste the time with reading. Let's just again, this picture. I find this picture very interesting. I find it very interesting. If you want an audience and you're a statistician, you must say, I'm talking about artificial intelligence. Then you've got an audience. Okay, we're about to close, colleagues. Statistical thinking. There's actually a very powerful quote. I don't think it's part of my presentation here. I was telling Prof. earlier about it from one of the presidents of think he was president of the American Statistical Association, who said one day statistical reasoning will be necessary for efficient citizenship as the ability to read and write. I think that is the day we're living in. You actually need to think statistically. Maybe not become a statistician, but you've got to think statistically, even when you are using GPT models, etc., etc. One has got to think statistically. Statistical reasoning, very important. Okay. Yeah, there you go. This is the quote I was referring to. Statistical thinking will one day be as efficient, necessary for efficient citizenship as the ability to read and write. I mean, one of my colleagues actually emphasizes on statistical literacy. So we've heard about mathematical literacy, but there's also need for statistical literacy. You know, of course, the role of the modern statistician now is more than just becoming a methodologist, but also an educator. I think I kind of fit there. I'm a proponent for, statistics for non-statisticians. So I taught big classes, in at Wits. I actually ran away. I hope my previous boss is not listening. But I ran away from my previous job because I was teaching big classes, And if you do something well, they give you more. So I got a bit of students voting for best lecturer, blah, blah, blah. But it was 1,200 students. And I developed some affinity with non-statisticians, teaching, there's a course called business statistics that I was teaching, mainly accountants and psychologists. You've got to explain what is a p-value without a formula to the psychologists. You've got to explain, I'm sure Prof understands what I'm talking about. You've got to explain what is a p-value without a formula. Okay, the probability of observing test statistic is extreme as the one you've got, assuming that the null hypothesis is true. But then how do you explain that? You've got to use maybe a judiciary example. What is the probability that someone is in the video footage if they did not steal whatever was stolen? If that probability is low, then what do? We reject the null hypothesis. So they are not innocent. So you've got to explain statistics in words. I think that project will be very good. I'm trying to get to that project where one can write a book to explain statistics in English, type of thing. But we'll get there. Okay. What else can we talk about? Of course, statisticians are not really confined to theory, but it's a critical architect for robust, ethical, and scalable data science and AI systems. Just a use case I was bringing here. We talked a bit about this at a radio interview. Cases of our colleagues sitting there. The probability of default problem is quite an important problem, but then how do you quantify uncertainty? Statistics comes in there again. Even to know that for the bank to give you a loan, it's really a logistic regression model that they use. They don't use sophisticated stuff. They use a statistical model. So statistics is very important, of course, in all these practical applications, even talking about healthcare, predictive modeling, risk stratification. I had a master student who published a paper on this during the COVID era. How do you know if someone tests COVID positive? How would you know that they actually need ICU? So that's a risk stratification problem. You can use some statistical model to do that kind of stratification of risk. Of course, I think there's other things. These slides are too many. It's almost 100. I'll send the prof for people who want to read. Explainable AI or machine learning, explainable machine learning. This stuff here becomes very important. Lime and Sharp, etc. Some examples to just show you that this is actually practical stuff. We're not talking about theoretical stuff here. People are using these techniques. Explainable machine learning. Look how much is going on there. This is just a screenshot. 2020, you can see the amount of activity there. People are actually using these techniques for different things. Interpretable machine learning, very similar to explainable machine learning. Again, a lot of activity going on there. Statistical machine learning. We've been talking about this. Look how much activity is going about on this as well. Bayesian neural networks. I love this. My students work a lot on this type of stuff. So think about your neural network as something that using big propagation and blah, blah, blah. You want to evaluate weights, to link certain features and the output, etc. But then instead of finding the weights in a deterministic fashion, you want to find a distribution over the weights. So again, once you start talking about a distribution, that's statistical theory. So Bayesian neural networks are very powerful. So you don't have one output, but you have a distribution over the output. And then that helps with quantification of uncertainty, etc. A lot of interest on Bayesian neural networks, actually. People are doing a lot with this type of approaches and probabilistic machine learning. Really preaching statistics here, right? Statistical learning, there's a lot of stuff there as well. Okay, I think we're almost done. A bit of reading there, which I won't bother you with. What is the conclusion today? Statistics is really, can be seen as the intellectual core, of course, from the foundational language of data science and machine learning. I mean, you cannot talk about data science without talking about statistics. That's the picture I'm trying to draw here. Neither can you talk about machine learning without talking about statistics. It is the statisticians' mandate to actually uphold the pillars of rigour, reproducibility, and interpretability, safeguarding integrity in data-driven systems, etc., your AI systems. I know they've been talking about auto-statisticians, etc., but I think you still need the human statistician in that system, Of course, we've got to elevate the need for statistical thinking. I think this is a send home. If you may please take this home. AI systems as they grow in complexity and influence. The need to embed statistical principles at a very early stage, or at every stage rather, whether you're talking about the design of the system and the modeling and the validation, deployment. This is very paramount. I mean, we cannot neglect the need for embedding statistical thinking in the whole pipeline. Okay. We've got to reaffirm the centrality of statistical thinking to shape the future where AI is not only powerful, but also trustworthy, transparent, and ethically sound. Okay. I mean, there's a lot of examples where AI systems are trained on a different population and people want to use it on another population. It does not work. Okay. That's just violating statistical principles. Okay. So what are we saying? Statistical thinking then is very important. Before you spend $1 billion to buy an AI that was trained on this type of population, to use it on another population, one has got to just have statistical thinking that these are two different populations before you waste $1 billion. Okay. In the era of artificial intelligence, it is statistical thinking that transforms data into understanding, of course. Okay. How can statisticians reclaim leadership in this revolution? Leadership in what? In data. I think the whole idea of data is statistical. And statisticians have got to reclaim. Looks like there's a lot of participants. I didn't know Prof was going to make me this popular. 74 participants. What are the barriers to integrating statistical rigor in modern machine learning pipelines? I mean, this is just a question I'm throwing out there. And in what ways can we strengthen the connection between statistical theory and applied artificial intelligence? I think questions can also be welcome for further reflection, etc. Thank you, Prof.
Yeah, Farai, thank you very much for the very interesting and entertaining talk. I think you suggest some points of discussion, but maybe the audience here and online has more specific questions. Let's start maybe with the audience here in the room. Any question? Zurab, I knew I could count on you. Microphone is coming.
Thank you very much for a very interesting talk. and also certainly very inspiring talk, also in terms of inspiring, making all sorts of jokes about all sorts of disciplines and so on. I was wondering, for instance, why is statistics a crack in the wall on your picture? But that's not my question.
Sure.
um, when we talk about the boundaries of a discipline and what a discipline really is, it is my personal opinion that I think all the disciplines that for which we've given names, starting with mathematics, but all the disciplines, it's rather a man-made thing. I think it's a bit like comparing a political map to a physical map. On the political map, you got those boundaries of countries. On the physical map, they're not visible because it's a man-made thing. And I think it's a bit similar in that regard, that these names we use for mathematics, physics, statistics, data science, these are man-made things which are just like the countries, just like the boundaries of countries. They're very temporary. In a given era, you've got certain boundaries. In a different age, you'll have different boundaries, and sometimes even different names. So, should we really insist on the concept of a field in an evolving world where these boundaries change? And if not, then what do you mean? But there is still something that you mean by saying that statisticians should reclaim. So what is really meant by that? Do you mean that you want to see more mathematics, more mathematical rigor into how things are done? Certainly, when you combine computer programming heavily with statistics, there is some kind of thinking that emerges there that might be not identical to the classical statistical thinking, and you've also explained that. So that's just a question/comment.
Sure. Should I go for it or should I take more? Okay. I think that's a very interesting one. And I do concur with what you're saying. I'm told by history that before there was any discipline, there was philosophy, which apparently included both science and religion. I don't know how true that is from a historical point of view. But the whole idea of disciplines, I guess, like you said, is man-made to the effect that you find historically people would be known as philosophers and they would do a lot of different things from economics to engineering to mathematics, like the Bernoullis and all that. So, I mean, seeing that we're here now, the point is it fair for a computing department, for example, I'm just giving an example, for a computing department to be running a data science program without the statistician on board? And that is the point I'm bringing. Is it fair for an engineering department to be running a PhD in data science without involving the statistician? And that is the point I'm bringing on the current date we are. Yeah, thank you. So sorry for answering a question with another question. Yeah, thank you. Thank you.
Any other question? Here, please.
Hello, how are you? Thank you so much for the wonderful talk. It was very amazing. I would like to ask a question regarding like ethics of sort. How do you believe like data scientists and statisticians can help with ethics? Say, for instance, if we what you got due to privacy of data, say for instance, there's collection of clinical data that can ensure that insurance companies might raise prices for some individuals if they have, say, a condition that affects their heart. How would you go about trying to prevent such ethical concerns?
I don't know if you knew that I teach an MBA class on artificial intelligence and healthcare analytics. It's a specialization at our school. I'm also marketing the school, by the way. So that's a very important one. When people give their data, give some kind of consent to, okay, but the data must be used for the purpose that it was collected. But who guarantees that? Who guarantees that? If I ask people here in the room, what do you think Facebook does? A lot of people would say Facebook is an entertainment, whatever, but it's not an entertainment business. It's a data business. They collect data. So they're using your networks to do a lot of marketing to your friends and. But the point is that ethical? Who guarantees that data is going to be used for what it was collected for? I think there's a lot of research there. What I'm trying to throw to you there is that our colleagues in law, for example, like where I come from, they're doing a lot of work in the ethics of artificial intelligence. There's a lot of work that has to be done there. If a self-driving car bumps into someone, who is liable? Is it the one who wrote the computer program? Is it the owner of the car? Is it the municipality? Who is liable? Again, questions. More questions than answers, I guess.
Follow-up question.
I have another question,
Sure.
but this is on something different. So you said an interesting quote earlier about what you call statistical literacy becoming just as important as writing and what you call mathematics. How would you say this would be implemented for, say, what you call younger children as well as college students?
Good, good. For college students, I think universities are already doing a lot in terms of, I don't know, it should be the same here, Prof, at Stellenbosch. Almost every program has a statistics element to it. Usually, whether you're doing the arts, they try and throw some statistic or something there. But I guess talks like what Prof is doing here and, I always felt that we need to have, statistics public lectures type of thing. But maybe NITheCS can sponsor me and I can teach that. Statistics public lectures, like they do sometimes in physics, or sometimes they have public lectures where everyone can come and learn. And maybe you can use jokes to make everyone understand what statistics is all about. I do that with my students. So I'll be happy to do that, Prof, if you can fund that.
You are NITheCS sponsored
Thank you,
shirt.
thank you. Yeah, for sure. For kids, I think the South African Statistical Association has been doing some good outreach. I think with Prof North from KZN, Prof Delia North. I think she's since retired now, but I think that program is still going with statistics education in high schools. They're even doing some videos now, I think, to help matriculants, etc., etc. I think instilling that thinking at matric level or even before statistical thinking, I think is very important. Yeah, some students don't do stats, but then they find themselves in finance or in other disciplines that actually require statistical thinking. Yeah. Thank you.
Christian, please. I think the microphone is coming so that Donovan can do his 10,000 steps today.
Sure. Thank you very much for your presentation. I'm taking a look at the second question you put up on the board there about the barriers to integrating statistical rigor into modern machine learning pipelines. I'm wondering to which extent that is not something that's already just happening, but there are different timelines to how rigor is brought into disciplines. There's an exploratory stage where one just needs to figure out how these things work and so on. So does one really actually need to do anything in order to lower those barriers, or should one just wait?
Yeah, I guess it depends on the nature of the project, etc. If it's such if you're talking about the whole spectrum, as it were, where it's not a project, which is timelines, I guess one can wait. But if you're talking about a project that has got a start date and an end date, and it's not indefinite, I think one might not be able to wait forever. One has got to maybe bring the statistical rigor maybe from the outset of the program. You want to make sure, for example, if you're collecting some form of data that is going to be used for some ML of some sort, one has got to make sure that the data is collected properly, of course. And I think that's part of rigor, validity, etc., etc. So I think the answer there could be yes or no. You could wait, but there's instances where you can't wait. I don't know if that's that suffices, but of course the underlying principle there is we've got to make sure that things are done properly, as it were. You know, you don't want to. I mean, you see some studies where someone does some form of linear regression. I'll use a very simple example: linear regression for categorical responses. You know, you've got a yes or no, but then you fit a straight line. So there's no answer there. You know, it's a wrong model. You know, there's no rigor. So, by the way, linear regression is a statistical model, but when it's applied in the computing environment, it's a machine learning model. That was a joke, but yeah.
Question at the back. Donovan, please. Thank you.
Okay, thank you for the interesting talk. Maybe just made an example about fitting a regression line when there is categorical debt. I assume that will be a student maybe doing that. But my question is, do we know of any cases where things have gone terribly wrong because people are using or are doing machine learning or AI without deep understanding of statistics?
Okay. This is where things have gone terribly wrong because people are using machine learning without a deep understanding of statistics. I think this is typical. This is typical. I've got to check my memory, but this is typical in a lot of application areas. I mean, of course, people won't come out and say the results were wrong and say what I published, I must retract it. But I mean, if you should just go to some of the medical journals, you find a lot of applications there where people utilize machine learning models to do some prediction, which is actually contrary to what will eventually happen in the medical journals and etc. I mean, you could look for good examples for that. Sorry, my memory doesn't serve me well there. Yeah.
Do we have questions from the online audience?
We've got two.
Okay, please, Donovan, can you kindly share with us?
Okay, first one. Thank you for your presentation. I feel the quality of the data plays critical roles in statistical thinking towards building a trustworthy AI. What is your position in building trustworthy AI within the African context, considering the orientation of the target participants during data generation? What are the issues and how can the issues be addressed to position African landscape among the global players?
Yeah, we've got data issues here in Africa. I've always discussed this with my students, particularly the MBA students, because you know they are kind of people who are making decisions in the industry. They are not undergraduate students. I was very hopeful when we had the national fourth industrial revolution, something here in South Africa. I was very hopeful that we could have maybe seen the development of data centers, etc. But I don't remember seeing anything to do with a data center. So if you want to look for data today, data regarding the country, I mean, the best place you could possibly go is maybe Stats SA. But what you get there, you get census data. But how about data to do with other sophisticated stuff? You don't find it. There's no center. I think that's something for Prof also to see if he can put money there. But I mean, if you're looking for data, traffic data today for the whole country, where do you go? If you're looking for how many people are flying in the air, how many people were in the air today in the country or last week, where do you go? You've got to dream about that data. So the deep learning industry, I think, have come up with something interesting now, where they are building a data repository for Africa, and they're asking people with data to kind of donate data there. I think overseas it has been done very well. But the point is, we actually don't have data. And I'm very surprised, actually, with our universities, why they would come up with. There's a lot of courses called big data something, big data something. I'm teaching one of those courses. But I don't know where the big data is.
Start collecting data for you.
Thank you.
Okay, one more question. Security is a major concern, especially when data collection is concerned. Learning modules collect this data and are mostly cloud-based. Who has access to this data and how secure is it?
That's the problem. That's the problem, which is one of the problems that people like our respected Professor Benjamin Rosman with the Mind Institute, they're trying to solve. I mean, Africa has been a consumer of all this type of stuff. I mean, you get an AI something that does ABC using a drone, this and this, and you're consuming. You just, even ChatGPT, we're consuming. I mean, whatever we're typing there, we're feeding into the training models and all that, and we've got to pay more. They're just going to increase the price based on our own data. You know, the context that we are bringing there, etc. And we own nothing. We own nothing there. You know, so how do we build our own systems that we can actually control? I think that becomes a very important question. Unfortunately, the poor you always have. Yeah.
Okay, are there more questions? Maybe something to end on a more cheerful note?
Sure. Maybe for you, Prof.
Okay. If there are no more questions, then Farai, it's my big pleasure to thank you very much for
Prof.
the great
Thank you.
talk.
Thank
Thank you
you.
very
Thank you.
much.
Thank you.
Next time we will give you a branded T-shirt.
Sure.
But in the meantime, we
Thank you.
just give you our magazine.
Thank you.
Bizarre. Thank you very much.
Thank you, Prof. Thank you. Thank you so much, colleagues.